This video will mainly discuss rational expressions and simplifying rational expressions and multiplying and dividing those. So there's no equations involved here. However, we will look at, with the calculator, what would happen if we did graph it as an equation in regard to excluded values. So I want to, when I say things like excluded values or what will cause an expression to be undefined, I will go to the calculator a few times with this video just so that you can see what I mean by an excluded value. So take an expression like this. It's not equal to anything. So basically we're looking at wanting to just simplify it. So what you want to think is, every time you're looking at these, is can I simplify the numerator? Well, no, I cannot. Now, can I simplify the denominator? And that is, can I factor anything? Okay, so we're going to rely on quite a bit of our factoring skills from exam 1 to simplifying rational expressions for this video. Well, they both contain a factor of 10, so I can divide each by 10, and I get 10 times x minus 1. That is, I'm finished with my denominator factoring, but now I also want to look at, well, can I simplify this 45 tenths? Okay, so, and yes, I can. So I'm going to leave the x minus 1, and then the 45 tenths, they both contain a factor of 5. So 5 divides 10 2 times, 5 divides 45 9 times. So what you have is 9 divided by 2 times x minus 1. Now, we have something we call excluded values. Now, what does that mean? Well, that means that what value for x could be substituted into the denominator to make the denominator go to 0, which would call it an undefined value. So when we look at the calculator, and you're going to y equal, I'm going to type in 9 divided by, in parentheses, 4, open parentheses, x minus 1, close it, close it. So, and I believe that simplified to 2 because I had 10, I had 45 tenths, so that would be a 2. And if I graph it, this is what that rational, if it was an equation, that's what it would look like. Well, if I go to second graph, there I'm looking at in my table of data, and I'm seeing that there's an error. And this error is at 1. I've got all these values, and if I go to my table set and start the table at 1, increase by 1. So I look at all of my values. I got an error at 1. Now, what does that mean? That means that if you substitute a 1 in for x, what it will result as is 2, 1 minus 1. And 1 minus 1 is 0, and 2 times 0 is 0. So you get an undefined value when x is equal to 1. So what we say is that, what are our excluded values? Our excluded values is when x is equal to 1. So therefore, x cannot be equal to 1 as part of the domain. So let's look at a second one. I get x minus 5 divided by this polynomial. Well, you look at the numerator, and there's nothing more that you can simplify with x minus 5. However, you always want to think, can I simplify? Can I factor? And we're going back to factoring skills, right? We can do that when A is 1, right? So we could think of 25. It's got to add to negative 10. We could think 5 and 5, both negative. And then we can also think, is this a perfect square trinomial? Is it a special product? And it is. 25 is a perfect square. X squared is a perfect square. So since it is, it would be x, 5, x, 5. And what's the sign? Remember, the sign comes from the middle term. Well, now everything is simplified. Everything's in a factored form. I don't want to divide out just yet. I want to determine what my excluded values would be, okay? And I actually have a multiplicity here. X cannot be 5, because when you substitute 5 in here or here, what are you going to get in the denominator? Well, if you substitute 5 here, you're going to get 0. Of course, here you're going to get 0. So you're going to get 0 in the denominator. So the excluded values would be x cannot be 5. Then you can go about dividing out. Okay? So what we want to say is find your excluded values before, that's just really sloppy, I'm sorry. Find your excluded values, then simplify. Okay, find your excluded values, then simplify. So these divide out. So what you're left with in the numerator is 1, and the denominator would be x minus 5. So here's your simplified form with excluded values of x cannot be 5. Let's take another one here. I've got x cubed minus 16. And I think I originally had an x there. So let me include an x in that part. So in the numerator should be an x can be factored. So that would leave me with x squared minus 16 divided by, each term has an x, so I'm going to factor an x, and then that would give me x squared minus 6x plus 8. So I'm looking at the numerator and I want to see what can I simplify. This should be a this should be a review from exam 1 because this is a difference of squares. So that would factor into a conjugate, x plus 4 and x minus 4, divided by, I have x times, now I need two numbers that multiply to give me 8 and add to give me negative 6, and it would be 4 and 2, and they would both be negative. So since a is 1, remember, I can look right here. And that would be x minus 4 and x minus 2. Before I start to divide out, what are the excluded values? E period, V period, excluded values. Well, x cannot be 0 from right here. You substitute a 0 in for x, you get 0, and 0 times whatever these would be, doesn't matter, would still be 0. X cannot be 4. X cannot be 2. So you'd actually have 3 places in the graph if we were to graph this expression. So let's look at that. That's going to be x cubed. So x cubed minus 16x, x cubed minus 6x squared plus 8x is what we're going to type into the calculator. So let me share that screen with you. Go to y equal and clear out. So in the numerator, I'm going to write x raised to the third minus 16x. Actually, I don't want that in the... I'm going to have to move my cursor over one more. There you go. Minus 16x, all divided by, and then I'm going to put in parentheses, x raised to the third power minus 6x squared plus 8x. I'm going to close that off, and I want to graph it. Graphing's not necessary for it, but I do want to see that we've got some, this is kind of how that graph would look. So second graph, I look at the table, and notice I do see some errors. X is equal to 0. When x is equal to 0, we have an undefined value. When x is equal to 2, we have an undefined value. And when x is equal to 4, it's undefined. So go back. We said 0, 2, and 4 as the excluded values. Now, coming back here, now that I've stated the excluded values, I can go ahead and simplify, and these will divide, and these will divide. So what I'm left with is x plus 4 divided by x minus 2 as my simplified form, and these would be my excluded values. Here we've got an expression that they almost look the same. I've got x minus 3 and 3 minus x. A very common mistake is for people to see the 3's and say, I'm going to divide those out, and I'm going to divide these out, and I'm left with 1 divided by 1, and it's 1. Okay? All right. That's incorrect. That's not going to work. Okay? X minus 3 is in the numerator. Now, I can flip this around by using commutative property, but I just got to make sure that x is negative. Now, so these aren't the same. However, if I divide out or factor out a -1 from this, that would give me negative x divided by -1 is x, and positive 3 divided by -1 would be -3. And now I have something where at some point I'm going to be able to divide these out. Problem is I need to find excluded values first. X cannot be 3 as part of the domain, because that's going to result in a 0 in the denominator. So once I've established that, now I can divide these out, and my answer would be -1. So there's my simplified form, and there's my excluded value. Given this expression, start to recognize some of these forms from exam 1. X squared minus 9, that is a difference of squares. That's going to be x plus 3, x minus 3, all divided by a is 1. I need two numbers to multiply to give me positive 6, add to give me 5, and that would be 3 and 2. So that would be x plus 3, x plus 2. And remember, I can take them from right there, those factors, because a is 1. So what are my excluded values? That's the question you're going to ask for each of these, is what are the x values that make this expression go to an undefined value? So x cannot be. We're looking here. And if it helps you, you can always set them equal to 0 and solve. So x would be -3 and x would be -2. So there you would say x cannot be -2 and x cannot be -3. So this would be your excluded value. And what would divide out? Well, these two right here would divide out, and you'd be left with x minus 3 divided by x plus 2. This would be your final result with the excluded values and the simplified form. Get to a problem like this. Very common mistake would be trying to divide with the 12 and the 20, trying to look for factors and look for factors here and trying to divide out the x's. Those are all really things that are just not part of our rule set when we're simplifying rational expressions. This calls for either a simplifying of the values here, or a distributive property. Now, the reason I'm hesitant on the distributive property, because if I distribute the 21 and distribute the 14, what I'm going to have to do is just factor out a common factor again. So what I'd like to do is I'm going to take the 14 and the 21. They both have a factor of 7. So 7 will divide both of those, and you will get 3 times 3x minus 12 and 2 times 5x minus 20. So this is one way to do that. We've simplified 21/14 to 3 halves. Now, if we look here, both factors have a 3 in common, and both factors have a 5 in common. So we could say 3 times, and let's factor out a 3. So that would give us x minus 4. And we could factor a 5, so I'm just going to scoot the 2 over, factor out a 5, and that would give me x minus 4. So this is going to be 9 times x minus 4 and 10 times x minus 4. Now, before I divide these out, which they will, I want to think, can I simplify 9/10 anymore? And I cannot. So my excluded values would be the only expression below. There's no variable with 10. There's your only variable, and it's in the denominator. X cannot be 4. If you substitute 4 in, you're going to get 4 minus 4 or 0. So my excluded value would be 4. Now I can divide those out, and I get 9/10 as a simplified result with the excluded value. All right, looking at this, I see squared terms. So I always want to think, and only see 2 terms. So you're always thinking, well, could a difference of squares work here? And that's part of exam 1. And that will be, because 4x squared is a perfect square, and 25 is a perfect square, and 9 is a perfect square, and 16 is a perfect square. And then 3x minus 4, they don't have anything in common, and 2x and 5 don't have anything in common either. So this would factor into a conjugate, 2x plus 5, 2x minus 5. Conjugates here would be 3x minus 4 and 3x plus 4. So before we start dividing out, we want to see what our excluded values would be. So if I take this expression, very similar to what we did finding solutions first during the first exam, is we set them equal to 0 and we solve. So 3x would be 4, x would be 4/3. So 4/3 would cause the denominator to go to 0. Subtract the 5, divide by 2. Negative 5 halves would cause the denominator to go to 0. So what are the excluded values? Well, x cannot be 4/3 and negative 5 halves. And then you go back up here and you look, what could we simplify? Well, this would divide one another because they're the same terms, and this would divide one another. So what are you left with? Well, you're left with 2x minus 5 in the numerator, 3x plus 4 in the numerator, with nothing in the denominator. So 2x minus 5 and 3x plus 4, along with the excluded values, would be your final simplified result of this rational expression. All right, I see multiplication. So again, I want to try to, you're always trying to factor as much as possible. You're looking for your excluded values, and then you want to simplify, seeing what will divide out. So x squared minus 8x plus 12. Well, a is 1. Factors of 12 that add to negative 8 would be -6, -2, they both add to -8. They both multiply to give me 12. So we know that would be x minus 6, x minus 2. 4x plus 16 would be 4 times x plus 4. And in the denominator, this is a difference of squares. X squared minus 16 is a difference of squares. That's going to be x plus 4 and x minus 4. And then this one right here would be a perfect square trinomial, because 4 is a perfect square, x squared is a perfect square. So x, that would be x, and then the sign would be negative, so x minus 2 and x minus 2. So we've simplified, we looked at our expression that was given, and we factored as much as we can, check. And now we're looking for all of our excluded values. So that's going to be in the denominator. There's where your eyes look, right here, 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 and here. So what can x not be? Okay, I don't want this, if this goes to 0, I have undefined. So x cannot equal -4. Here, x cannot equal 4. X cannot equal 2. And this was perfect squares, so these were repeating expression, also called a multiplicity of 2. So what are my excluded values? Excluded values are x cannot be 2, 4, or -4. And now we want to see, okay, well, what will divide out? Well, the x minus 2 and x minus 2, the x plus 4 and the x plus 4. So what are we left with? We're left with 4 times the remaining. So that would be 4 times x minus 6, all divided by what's left. X minus 4 times x minus 2. And we're good to leave it like that with the excluded values. X squared minus 16, that ought to be continue to be, help you with your recollection that that's a difference of squares. So that'd be x plus 4, x minus 4. There's your conjugate. And then here, I need a is 1, so they need to multiply to give me -12, add to give me -1. So that would be 4 and 3 and -4. So -4 plus 3 gives me -1. -4 times +3 gives me -12. So since a is 1, remember, I can go directly from there. X minus 4, x plus 3. So again, I want to factor as much as possible. I want to look for the excluded values in the denominator, and then I want to simplify. You're going to see that process over and over, especially with our simplifying of rational expressions. So excluded values. Excluded values, your eyes, like I said, go to your denominator. The more you work with this, the more you start to see, well, what's the value that I could substitute to make it go to 0? So x cannot be 4. If I substitute a 4 in there, it goes to 0. So I want to stay away. I cannot include that in my domain because it will cause an undefined value. And what else? X cannot be -3. So those are my excluded values. And then you're back to, well, I factored, I did my excluded values, now I'm looking to simplify. Anything that will divide out, yes, the x minus 4s will divide out. So what are you left with? Well, you're left with x plus 4 divided by x plus 3. And that, along with the excluded values, would be your simplified form. So you're seeing there's a lot of factoring that's coming back. We're really not dumping that knowledge and setting that aside. We're continuing to use that to help us simplify rational expressions. With this example, we notice that we've got a couple where a is not 1. but we also have a possible perfect square trinomial. And so again, we're thinking, well, we need to factor. I'm looking for excluded values in the denominator. And then I want to simplify. So that's kind of our thought process as we go through the problems here. So 4x squared plus 4x plus 1, well, I recognize that to be a perfect square and that to be a perfect square. So based on our exam 1, our special products, this would be 2x and 1, 2x and 1, and remember where the sign comes from is right here. The second one, I need 2 factors that multiply to give me -4 and add to give me 3, which would be 4 and 1 with -1 and a +4. So since A is 1, I can go directly from here. So x plus 4 and x minus 1. So we're going to divide that. And what can, okay, there's only 2 terms here. So you look for what's in common. They only have x in common. So that'll be 2x plus 1. And then here, I've got another one. A is not 1. So what's 2 times -1? Well, that's -2, and it's got to add to give me -1. So that would be 2 and 1, -2, +1. Since A is not 1, then I need to go through my factor by grouping. So that'll be 2x squared. Remember, that's coming from the first term. Minus 2x coming from here. Plus 1x coming from here. And minus 1 coming from that last term up here. So we're going to factor, and we're going to group, and then we're going to factor. So 2x, so that'd be x minus 1. And the only thing in common here would be 1, so that'd be x minus 1. So how does it factor? It'd be 2x plus 1 and x minus 1. So where does that go? Well, that goes right next door to the x times 2x plus 1. So that'd be 2x plus 1 times x minus 1. So that's quite a bit of factoring there. What are the excluded values? I's go to the denominator. I see just a lone x, so that means x cannot be 0. I see repetition between, so that means 2x plus 1 is equal to 0. Subtract the 1. X cannot be -1/2. And then this one right here, x minus 1, so x cannot be 1. So those are the excluded values. And then you look at what you can divide out. 2x plus 1, 2x plus 1. 2x plus 1, 2x plus 1. X minus 1, x minus 1. And what are we left with? An x plus 4 in the numerator and an x in the denominator. So all of that simplified to this expression. So that expression, coupled with all the excluded values, would be the simplified form. Okay, again, I've got some factor by grouping. So I'll take the top expression, and that's going to be -72. 6 times -12 is -72. It's got to add to give me a +1. And that should be 9 and 8, and 8 negative. So that'll give me 6x squared minus 8x plus 9x minus 12. So I'm just factoring this trinomial. So I got quite a bit of factoring to do here. So this will be 2x. So that'll be 3x minus 4. 9x and 12 would be 3. So that'll be 3x minus 4. So the top part of this rational expression will be 2x plus 3 and 3x minus 4. So that's coming from here, and that's factoring this expression, or that trinomial. So now let's come over here. I've got 3 and positive 8, so that would be 24, and it's got to add to give me negative 14. So it looks like negative 12 and negative 2. Those are both factors of 24. They both multiply to give me positive, and they both add to give me negative. So 3x squared minus 12x plus a negative 2x, and it's going to, and then a positive 8. Okay, so group factor, that'll be 3x and x minus 4, and factor out a negative 2, and that'll be x minus 4. So 3x minus 2 and x minus 4, 3x minus 2 and x minus 4 as this trinomial on the top right. Bottom left is 2x squared minus 5x minus 12. Well, that's going to be 2 times negative 12, so that's going to be negative 24. It's got to add to give me negative 5, so I'm thinking 8 and 3, negative, positive. So that'll be 2x squared minus 8x plus 3x minus 12. So this is all review from exam 1, factoring when a is not 1. So we're going to group. GCF would be 2x, so x minus 4. And this is 3x minus 12, so a GCF of 3, and you get x minus 4. So that would be 2x plus 3 and x minus 4 for the bottom left trinomial. One more. I have 9x squared minus 18x plus 8. And remember, 9 times 8, that's going to give me 72. And it's going to be positive 72, but it's got to add to give me negative 18. Positive 72, add to give me negative 18. Should be 12 and 6, both negative. So that would be 9x squared so that'll be 9x squared minus 12x from here, plus a negative 6x from here, and that last term is 8. So we're going to group factor, so this GCF will be 3x, so that'll be 3x minus 4, and 6x and 8 would be 2, so that'll be 3x, and since that's a negative, forgot that, so I'll be careful there. That's a negative, it's kind of hidden there. That's a negative 6, that'll be a negative 2, so that'll be 3x, and then 8 divided by negative 2 would be negative 4. So you're going to get 3x minus 2 and 3x minus 4. So those would be placed right here. 3x minus 2, 3x minus 4. 3x minus 2, 3x minus 4. And now before we start dividing things out, you check your denominators here, 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 and here. So excluded values. X cannot be. Take 2x plus 3, set it equal to 0, and you're going to subtract a 3, divide by 2, you're going to get negative 3 halves. This will be x cannot be 4. This would be add the 2, divide by 3, so can't be 2/3, and add the 4, divide by 3, it can't be 4/3. So there is your excluded values, and now what will divide out? 2x plus 3, 2x plus 3. X minus 4, x minus 4. 3x minus 4, 3x minus 4. Look at that. They all divide out. It results in simplifying to 1. Now, this is a little different. Not much, but we see a division sign. And so the division with fractions, remember, anytime we divide with ratios, one method is we can multiply. We can change it to multiplication, but we would have to take the inverse of the second fraction. So we would have to take the inverse of this. Very similar to when we divided fractions. So let's say we got 1/2 divided by 1/4. So imagine this being 1/2 divided by, imagine this being 1/4. So when you divided fractions, there's multiple ways to do that. Taking a number and dividing it by 1/4 would be the same as taking a number and multiplying it by its inverse. So then you would start to divide out and simplify, and in this case you would get 2 as a result. Well, we want to do that same idea here. So I get x squared minus 16, and that will factor. And lost my place there. Here we go. So x squared minus 16, that's a difference of squares. So that would be x plus 4, x minus 4. And what else do we have? We have 4 minus x. And then we have x squared plus x minus 12. So it's got to multiply to give me 12, add to give me 1. It's got to be multiplied to give me negative 12, excuse me. So that would be 4 and negative 3. So this would be x plus 4 and x minus 3. And then we've got x squared plus 2x minus 15. A is 1. So 5 and 3 with a negative 3. So 5 plus a negative 3 gets me 2. So that's going to be x plus 5 and x minus 3. So what are my excluded values? Okay, x cannot be 4. Excuse me, negative 4. X minus 3. X can't be 3. X plus 5. X can't be negative 5. And x minus 3. Again, these are repeating, so I only have to write it once. So now we look at what's going to divide out. X plus 4, x plus 4. So these will divide out. X minus 4, x minus 3, x minus 3. Nothing seems to divide out here. However, this 4 minus x can be rewritten. Because remember, it can be rewritten as negative x plus 4. All divided by, well, here I've got x minus 3, x minus 3, and x plus 5. So we could factor out the negative here, and we could say negative 1, and then that would be x minus 4 and x minus 4, all divided by x minus 3, x minus 3, x plus 5. So this would be left in factored form. We could take it one more step, and we could say x minus 4 quantity square and x minus 3 quantity square times x plus 5. So we know that nothing else will divide out. This would be appropriate. This would be appropriate. This is okay. This could be simplified just because the negative x plus 4, just dividing out, excuse me, dividing out the negative 1 along with our excluded values. So we really only had one set of expressions that divided out. Again, this one, notice how it's written. This is what we would call a complex fraction. So don't let that scare you. That just means that this division bar right here is the same thing as this one right here. So you see division, you are welcome to change that to multiplication. You're just going to have to take the inverse of the fraction that's dividing into this. Okay, so that would be x minus 8 and x plus 8. So I just changed that to multiplication, and then I'm looking to simplify this. This is a recognizable, I recognize this, yeah, both of them to be perfect square trinomials. So this would be x, 8, and 8. Middle sign is addition, so it'd be x plus 8, and we've got the same thing below, so it would be x minus 8 and x minus 8. So what are the excluded values? Denominators. X can't be 8, and these are repeating, so x cannot be 8, and x cannot be negative 8. And then you start looking at what will divide. Well, x minus 8, x minus 8, x plus 8, x plus 8, and you're left with x plus 8 divided by x minus 8 as the simplified rational expression. Same thing here. We see the division. We see this is just a complex fraction. It's saying this expression divided by this expression. So write it however you like, or understand that since you're dividing, this is this expression that's going to have to be reciprocated, just like the second fraction here would have to be reciprocated. So I'm going to 5x minus 3. There's nothing I can factor. 4x squared minus x minus 3. Well, that would be negative 12. A times c. It's got to add to give me negative 1, so it'll be 4 and 3 with a negative 4. So that'd be 4x squared minus 4x plus 3x minus 3. Group and factor, so that would be 4x. So x minus 1, divide out the 3, x minus 1. So this denominator would be actually be 4x plus 3 and x minus 1 from right here. And then I'm changing it to multiplication. So this denominator is now, when you take the reciprocal, will become in the numerator. So I'm looking at what do they have in common. They both have an x. So I would divide x by both of these, and I'm going to get 4x plus 3. And then remember, this was in the numerator, but since I took the reciprocal, it's going to go in the denominator. And they both have an x squared in common, because this has an x cubed and this has x squared. So that would be 5x minus 3. So I do see some things that would divide out, but excluded values first. X cannot be, this is 4x plus 3, so I would subtract the 3, divide by 4, negative 4/3. X cannot be 1, x cannot be 0, and x cannot be, let's add 3, divide by 5, we would get 3/5. So those are the excluded values. And now you're thinking, what will divide out? 5x minus 3, 5x minus 3, 4x plus 3, 4x plus 3. This is x and this is x squared, so one of those with one of those, and you're left with 1, because there's nothing in the numerator, but there is a 1, divided by 1 lone x times x minus 1, along with the excluded values. All right, so your check for understanding. These are already factored. So 3 times x minus 6 divided by 3 times x plus 3 times x plus 3 divided by 4. You start to, well, okay, I've already done all my factoring. This is your thought process. That's done. Next is I want to look for my excluded values, and then I want to simplify. So excluded values on number 1 would be x cannot be negative 3. Don't worry about the 4. Don't worry about the 3. Why? Because the 4 doesn't have a variable with it. Neither does 3. This expression right here, x plus 3, you set it equal to 0, or you substitute a negative 3 here, you will get 0 as the denominator. So here's your excluded value. X cannot equal negative 3. And then you start to look at what will divide out. This will divide, this will divide. 3's will divide. You're left with x minus 6 divided by 4 coupled with your excluded value. So that's the check for understanding number 1. Number 2, notice you see the division. So that would be x plus 3. And some students like to just go ahead and rewrite it as multiplication, which means you're going to have to reverse these, take the reciprocal. So that would be x minus 1 quantity square and x squared plus 2x minus 3. So I rewrote it as multiplication, but I took the reciprocal of this ratio. I want to get into factored form. So this will be x plus 3 divided by x plus 2 times, this is a perfect square trinomial. The length and width are both x minus 1. And then this one, a is 1, but I need to look for factors that multiply to give me negative 3 and add to 2. So that would be positive, oh, sorry, too fast. Multiply to give me negative 3, add to give me positive 2. So since a is 1, I can go directly from here, x plus 3, x minus 1. What are the excluded values? We've done our factoring. Excluded values, x cannot be, you're looking at your denominators, x cannot be negative 2, x cannot be negative 3, and x cannot be 1. Once you've stated those, remember, you get to divide out x1. X minus 1 will divide x minus 1, x minus 3, and x minus 3. So what are you left with? X minus 1 in the numerator, x plus 2 in the denominator, along with the excluded values. So remember, you want to factor as much as you can with a rational expression. And even when we get into equations, we're always going to be thinking, can I factor? Let me get everything into factored form. Once they're in factored form, I want to look for my excluded values and state those. I want to state those before I simplify.